this example, I will show you how to de-identify a registry dataset. In this case, I'm using the Privacy Analytics tool, which is a de-identification engine. So the first thing I will do is load the dataset. In this particular case, I am using an extract from a birthing registry in Ontario, and this consists of baby and mother information for all births in the province. I'll use that as an example. Now, this registry has a lot of demands on it for secondary use. Of course, de-identification is a big issue before data is disclosed, for example, to researchers. First off, I will just describe this number here, which is the re-identification probability. This essentially sets the limit on how much the data custodian, in this case the registry leadership, how much risk the custodian is willing to take. 0.2 represents the probability of re-identification. So if we move this number higher, it means that we trust the recipients because we're going to allow a higher risk of re-identification. And if we move this number lower, it means we trust the recipient less, because we're allowing less risk of re-identification. The default is 0.2. We've chosen that default because that represents what the community has been using in practice today, and there's a lot of precedent and existing policy to support that. So I'll keep it at 0.2 for now, and then I will select the variables. To start off with, I will just select those three variables: the maternal postal code, the baby's date of birth, and the mother's age. These are basic demographics, and they can be used to re-identify records in this registry. Now, recall there are no names or anything in this registry, right? We're just using these indirect identifiers. Then we'll do a re-identification risk assessment on this data set. So we're going to determine how easy to re-identify records in this data set. We're mainly concerned about the mothers. First of all, let's look at this dial, which shows 100%. This basically indicates that 100% of the records in this registry, in this extract from the registry, are high risk. It means essentially that the risk of identification is higher than the threshold we have set. Basically, it never released this data set because everybody in this data set is at risk of re-identification. Up here we have two kinds of re-identification risks that we are concerned about in this registry, and they both indicate that the risk is very high. Essentially, the probability of identification is equal to 1 for both types of risks: prosecutor risk and marketer risk. So we've done the risk assessment, and now we realize that just on these three variables the risk of identification is high. We will move on to de-identify this data set. The automatic de-identification algorithm that we're using is going to be published soon in the Journal of American Medical Informatics Association, and it's an optimal algorithm, and we've provided evidence that it's one of the fastest algorithms that exist today for identifying large data sets. So I will define here hierarchies for each one of the three variables that we're dealing with. So for postal code, we have the 6-digit maternal postal code. It can be generalized to a 5-digit one, 3-digit one, or a 1-digit one. This is a generalization hierarchy. And then we have the baby's date of birth. Again, we can have date, month, year, and quarter year as the generalization hierarchy for this. And then the mother's age. So we're going to have the mother's age as it is, 2-year interval, 5-year interval, or a 10-year interval. So these generalization hierarchies come from a library that are available with the tool, and they allow you to define the different acceptable granularities or levels of precision of the data set. We can also assign weights. So let's say we're going to assign a lower weight for mother's age because it's less important for the type of analysis we want to do, and an even lower weight for the maternal postal code. And these parameters can be set depending on the specific purpose of the data. For some analyses, some variables will be more important than others. The weights basically tell the algorithm to try to preserve the integrity of the more important variables, to generalize them less if possible when trying to come up with a solution. And now we're going to run the de-identification algorithm, and this will produce a globally optimal solution. This is the best solution that it could find. And the solution guarantees the risk of de-identification is below our threshold. So here it is. Here's our first solution. I'll put it right here. And as you can see, the risk of re-identification is below the threshold, so we've guaranteed that the risk is below 0.2 in this case. And what we've done here is the mother's age remained the same. The baby's date of birth has been converted to quarter and year, and the postal code has been generalized to the first character only. So this is the generalized data set, and we can export it now and essentially produce a generalized version of this data set. Now some users might say, well, this is too much generalization. Can we find a solution that has less generalization in it? So what we can do then is go back, and the first thing we can try is to modify this threshold. So I'm going to change it to a higher value, to just over 0.33. Now again, we can justify 0.33 because there's a lot of precedent for that. When we looked at policies and procedures that health custodians have been using, some of them have used a higher threshold. To justify this higher threshold, of course, the custodian has to impose more restrictions on the recipient. They may ask them to implement more security and privacy practices, to have audits in place, to certify that the practices are in place, to certify compliance, and so on. So there are certain rules that need to be put in place to allow you to increase your threshold, and we have a whole methodology for reasoning about this. Then we're going to do the risk assessment again at the higher threshold, and as it turns out, the risk of identification is still high at the higher threshold, again 100%, and the prosecutor and marketer risks are at 1. We will apply the de-identification algorithm one more time here, and we will do the optimal, and basically what we did last time, define the hierarchies, and then we're going to run the same algorithm on this data set to see what kind of generalization or results it produces compared to when the threshold was lower. Okay, and then we will proceed here and de-identify this data set. And it'll take a couple of seconds here to produce the de-identified version. Okay, as you can see here, again I produced a de-identified version of this data set. The difference here is that the mother's age is in 2-year interval, but the baby's date of birth now is month and year, and the postal code is still the first character only. So by playing around with the parameters, one can get different solutions. We can change the threshold. As you can see here, there's a suppression limit. That's another parameter that can be changed. And by playing around with these different knobs, essentially, we will get slightly different solutions. And they all guarantee that the risk of identification is below the specified threshold. And the end user can then decide which one of these data sets is acceptable for the particular purpose of the analysis. Thank you. That's a quick example of how to do the identification with the privacy analytics tool.